Day 77 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. Hope you guys are feeling refreshed. Hope you guys had a good night's sleep, and I hope you guys are excited for the LeetCode problem that we have here today. Now, before we get started, don't forget, guys, don't forget, bring your mouse, bring your mouse, bring your mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers, all of my bankers. This is not a drill. I need all of my bankers in the comments section right now, dropping 2 bank emojis in the comments so we could run this engagement up and we could bring more awareness to the Swift community and help build the Swift community as a whole, guys. Now, I know why you're here. I know why we're all here. We're all here for a LeetCode problem. And today we have question number 62, unique paths. The difficulty levels medium, but you guys already know we're going to keep the solution as simple and easy to understand so that we all can learn. We're all trying to learn here, and there's no point in writing code that nobody's going to understand or nobody can learn from. So, with that being said, let's take a look at what the question is asking. The question says there's a robot on an M times N grid. The robot is initially located at the top left corner, i.e. grid 0, 0. The robot tries to move to the bottom right corner, i.e. grid N minus 1 and N minus 1. The robot can only move either down or right at any point in time. Given the 2 integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 2 times 10 to the 9th power. So let's look at example 1. Example 1 has a picture, but the output is big, so I'm not going to be able to explain it as well as I will with example 2, but we're going to look at it anyway. In this case, m equals 3, n equals 7. So m is the height, which is 1, 2, 3, and n is 7, which is the length, which is 1, 2, 3, 4, 5, 6, 7. So that's what the inputs represent, the height and the length. And in this case, the output is 28. That means there are 28 different ways that this robot can get to this star, taking a unique path, meaning a path that it did not take before. So there are 28 different ways it can do that. We're going to look at example 2 so it will be a little bit easier to understand, because that's 28 paths that, we could go through each 28 paths, or we could just look at example 2 with a shorter path and show you that way. So we're going to look at example 2. In example 2, m equals 3 and n equals 2. So that means m equals 3, which means the height would be 3, 1, 2, 3, and n equals 2, so it would be 1, 2. So we're going to just look at this square or this rectangle right here, this 3 by 2 grid right here. We're going to ignore all this for the example 2. So in example 2, the star would be right here in this square right here, and the output would be 3, because from the top left corner, there are only a total of 3 ways to reach the bottom right. Right down, 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 right, or down, right, down. So let's look now. Like I said, this is a little easier example to show you. So in this example, to get to this star, one path it could go to the right one, then it go down, down, and that'll get to the star. Or we could go, start here, we could go down, down, right, and that go to the star. Or we could go down, right, down, and that will get us to the star as well. So those are the only, if the star was right here on the 3 by 2 grid, those would be the only 3 unique paths that this robot can take to get right here. And again, guys, we're ignoring all this over here because that's example 1. That's an m by 7. Example 2, that's a 3 by 7. Example 2 is a 3 by 2, so it would be right here. And these right here are the 3 unique paths that this robot could take to get to this square right here. So now that we see what the question is asking, let's get into the code. And the code is actually not that difficult, guys. It's going to handle a lot of the hard stuff for us. So the first thing we are going to do is we're going to declare a variable, and we're going to call that last row. We're going to set that equal to an array of repeating, it's going to have repeating 1, and the count is going to be n. So that's how we're going to initialize the array with. It's just going to be repeating ones of count up to n. Then we're going to come down here and we are going to say for underscore and 1 up to m. Then what we are going to do is we are going to say declare another variable, and we're going to call this curve row, and we're going to set that equal to an array. Again, this time it's going to be the same thing. It's going to be repeating 1. Then we're going to say comma count. Count n. So it's going to be the same thing as as last row basically, but that's just how we're going to initialize it. As the code goes on, the code will append certain things into these arrays that need to be appended into these arrays. So after we do that, we're going to say for j in stride. Then we're going to say from. We're going to say n minus 2, comma. Then we're going to say through. Then colon 0, comma. Then we're going to say by colon -1. We're going to come outside those parentheses, open up the brackets, and we're going to say cur row, j equals cur row. Open up the array brackets, j plus 1. Then we're going to come outside of that and we are going to say plus. Then we are going to say last row j. Then we're going to come down here outside of that bracket. We're going to say last row equals cur row. Then we're going to come down here and we're going to say return last row 0, guys. And now let's run it and see how it runs. Fingers crossed, fingers crossed. No bugs, no typos, and it's accepted, guys. That's what I'm talking about. That's what I like to see. So let's submit it and see what happens when we submit it, guys. All right, 5 milliseconds beats 24.14% of users with Swift, guys. Not too bad, not too bad at all. The solution wasn't that hard, so I hope you guys, there's no reason that this solution or this problem should add to your burnout, because this solution was that easy where it's no problem. Now, let's go. After we do that, let's study the solution. Let's understand it, read it, learn it, love it. And I'll see you guys tomorrow for another day, another LeetCode problem. Peace.